In this tutorial, we will see about rounding functions. The first one is round. It rounds with respect to 0.5. So what does it do when the numbers are below 0.5, exactly 0.5, or even negative? Well, 2.4 is less than 2.5, so it rounds down to 2. 12.5 is exactly on that limit, it rounds up. And negative 6.67 is below negative 6.5, so it rounds down. So the answers would be 2, 13, and negative 7. For the negative, if you want to remember a little trick, take away the negative, do the math as you would normally, and put the negative back. The next one is ceil. This one rounds towards the ceiling, so towards plus infinity. In this case, all numbers would be going upward. So 2.4 would become 3, 12.5 would become 13, and negative 6.67 would become negative 6. The opposite of ceil is floor. Floor rounds towards the floor, so down negative infinity. So in this case, we'd end up with 2, 12, and negative 7. So let's see this tutorial through a lot of examples. Imagine you have to build stairs, and you have to determine how many bags of concrete mix you have to buy. Like, if you go to the store, you're not going to be able to buy a decimal amount. But mathematically, chances are you'll end up with decimals, so rounding is a necessity. If one bag can cover 0.1 feet cubed, all we need to know is the total volume and then divide by 0.1. So the given needed are height, width, depth, and number of steps. We need to find the quantity of bags needed. As far as the theory, again, it's just a simple equation. Height times width times depth will give us the volume of one step times the number of steps. Then we divide by 0.1 because that's how many feet cubed one bag can handle. Since we're dividing by a decimal, again, chances are we're going to end up with decimals. So we will need to round up. So, a quick example. Assuming we want 4 stairs, or 4 steps, 3 feet wide, 7 inches tall each, and 11 inches deep each. As far as the total volume that we're going to need, it's a simple multiplication. Don't forget the unit systems. We have inches and feet, so everything needs to be moved back into feet. So we end up with 6.42 feet cubed, and when we divide by 0.1, which is one bag, then we end up with 64 bags. It's so close to 64, but we still need to buy 65. Can you already guess which function we're going to use? Let's go see in MATLAB. So the first thing we need to do is an algorithm to lay out our plan before we even start coding. The first thing we need to dimension is our step. Length, width, height, in feet. Then the number of steps total. Calculate the total volume and find and display how many bags. Of course, we're going to round up. I've gone ahead and filled in all the givens that I knew. 3, 7/12 to convert to feet, and I'd rather ask MATLAB to convert for me instead of doing it on paper separately and already introducing round-off errors. Then I can already code the equations, and I choose them to do 2 steps, one for the volume, one for the number of bags, just so that I can test easily. I get 64.16 bags, which is what I had on paper. But now I need to round up and display the result. Now in order to round up, I've already got enough printf statement ready. I'm going to put a semicolon, but between number of bags decimals and number of bags, I need to calculate the number of bags. So number of bags equal, and we already knew that we wanted to round up. So it's the ceil function. And within the actual argument, I indicate which variable I would like to round up. So in this case, I will need to buy 65 bags. Now notice that now that I've converted the actual variable to an integer, I no longer use %f. I'm very cautious as far as showing the amount of decimals. Number of bags no longer has a single decimal since we rounded up the value. So %d is more adequate than %f. You could have done it another way as well. For example, back to where we were. Instead of creating a new variable and actually rounding up, I could immediately go to the number of bags. So no longer any more decimals. But in this case, I need to ceil the actual equation. So the argument of this function is an actual equation this time. But the result is identical. So those are two ways you can do it. Either you apply the ceil function to your equation immediately, or you create a second variable where you actually convert. So go ahead and test your understanding. In one of the other classes related to engineering is EGR115, Introduction to Engineering. And in one of the projects, the rocket project, you have to determine how many engines you're going to put on the rocket. Now, through extensive calculations, you know how much thrust is needed overall, and you have picked an engine, so you know the thrust of one engine. So it's a simple division, but which rounding function will be used to conclude? Obviously, you're going to get decimals again. So do you want more engines or less engines? Floor, ceil, or round? Or maybe no rounding? Of course, it's going to be the ceiling. You better have more engines than not enough. Now, there is a very common mistake when learning to use these functions. You have to remember that these are functions that return a value. So you must collect them or use them immediately in your equations. For example, suppose this is the answer to the rocket project. Imagine, again, through extensive calculations, you've found that you needed 289,000 pound force of thrust, and 30,000 pound force is provided by one engine. Answer by a yes or a no. Will this provide the right number of engines? You must be sure about your answer, either a yes or a no. I ran the code. Now obviously 9.63 is not the right answer. Now if you look at the ceil function, it was used properly. The ceil function is indeed receiving an argument, the number of engine that was calculated just above. However, you did not return the value into a variable. So MATLAB just temporarily rounds the number, and you can see it went into ANS, but it never made it back to the number of engines. It is possible, completely possible, to override a variable by a new value. That is perfectly fine, but it needs to be done. Ceil alone will temporarily round, and that's a very common mistake. So remember that the ceil function returns a value and you need to collect it in a variable. So in this case, it rounds properly. Let's see another example. Given a whole amount of seconds, convert to a format hour, minute, and second. That might be useful one day if you're doing a trajectory problem and you don't want to show an answer in number of seconds. 5,623 seconds. How many hours, minutes, and seconds is that? Well, first you want to find the number of hours. So by dividing by 3,600, you convert to a number of hours. But you're getting decimals again. That gives us 1.5 hours. But that's one full hour. So that answers our first dash at top, but after that we still have to figure out the minutes and the second. To figure out the minutes, you could take the 0.564 and multiply by 60. But here you're introducing again round off issues with decimals. So instead I prefer going a second way of finding how many minutes are left and playing with that whole value. From the original amount of seconds, I take away that one full hour that I found. So I have 2,023 seconds left. That's easy to convert to minutes. 33.716 minutes, and again, I round down. So that's 33 full minutes. And finally, using the number of seconds, well, from the number of seconds that I had left, I subtract those 33 whole minutes, and I get 43 seconds. So again, there is a couple variations of solving this problem, but this one allows no round-off issues. Now, as far as coding it, it would be using the floor function. Now, here we're going to ask the user for how many seconds. So in this case, I will first do an introduction before I ask the user. Then, in the order I solved on paper, I will do the hours, then the minutes, and then the seconds. Once I have everything, I can show the time. So I've gone ahead already and done the introduction and asked how many seconds. To find how many hours, again, we divided the total second by 3,600. And then we rounded down. Remember to collect the return value, otherwise we won't be able to keep that value anywhere. So that's the amount of hours. Let's see if it works already. 5623. So that's 1 full hour. Okay, so far so good. So let's do the minutes. Now as far as minute variable, min, you'll learn later, is a keyword. So I'd rather not use a keyword that MATLAB already knows. So I will type out minutes. And let's do the total seconds minus how many hours I have times 3,600. So that again matches my paper. But that's not exactly what I'm interested in. I want how many minutes there are in those 2023 seconds. So I will take again the conversion factor. And then I needed the floor of that. So I could again separate this into 2 lines, or I could just combine it by using the floor function. So far again, so good. And then find how many seconds. That is again the final result that we had. So let's see if the fprintf works. Nope, wrong variable name. So that's 1 hour, 33 minutes, and 43 seconds. Just to make sure, let's do obvious numbers. 3,600. That's 1 hour, 0 minutes, 0 seconds. How about 60? That's 0 hours, 1 minute, 0 seconds. Okay. How about 2 seconds? 0 hours, 0 minutes, 2 seconds. Test a lot of the special aspect of your code. To be honest, the result is good, but it's not really looking like a clock. So let's tweak it a little bit just to make it perfect. Let's already introduce 2 field width. Remember that that number without the dot is the number of places you want the number to take, and it will be aligned right. So let's do it again with 3,600. It's already starting to look like a clock because there's 2 spaces in each spot. Notice how the 0 is no longer attached to the colon. But the best thing that could happen if this was already filled in by a 0. Fortunately, it's really simple. Add a 0. So 0 in the hours, 0 in the minutes, and 0 in the seconds. That number comes before the 2. So now it looks like a clock. Let's do 65 seconds. That's 1 minute and 5 seconds. To be honest, 0 is the only one that's possible. If you put any other number, like a 1, MATLAB will use it as 12 field width. So 0 is the only option, but it's very practical for clocks. 9 minutes and 24 seconds. So that concludes it. Remember here we used the floor function, but I worked in steps. I coded a little bit, I tested. I coded a little bit, I tested. I chose to do this one line in one shot, but I could have separated each operation in 3 lines. You can be more comfortable doing 3 lines and not messing up the parentheses instead of one full line where you're trying to stay on track each time. So keep in mind this is one of the options. Before we conclude on this lesson, try it yourself. Give it a shot. Suppose an ID number is this number, and we have to isolate the last 4 digits. This is a very common operation when we want to display your grades. So how do we do it? Mathematically, it's nothing but a subtraction. But how do we get that middle number? Well, it's again just math. We divide by 10,000 so we can move the decimal period all the way up to the last digit we want. And then we use the floor function. That will give us 1394 only. And if we multiply that number by 10,000, then we're back to the middle number. Try to code that. Give yourself some kind of practice to understand those rounding functions. Alright, so let's conclude. The key points of this lesson is 3 new functions: round, ceil, and floor. Round is with respect to 0.5, the other 2 is positive or negative infinity. We used a lot of examples here. The cement mix for the stairs as well as the rocket used ceil. The time formatting used floor, and the ID number is as floor as well. Now, remember to collect the return value. Again, calling the function alone will make a temporary change to your variable, but will not take it further down. So always collect the return value in a new variable.